random forest classifier, decision tree classifier, and logistic regression practical, and then theory of KNN and practical of KNN, right? So whenever it comes to KNN is called as a lazy algorithm because it will take more time for testing than training. The reason is it has to calculate the distance of each and every point or each and every observation on the graph, and then it has to classify it whether that belongs to this class or another class. So this is what about KNN. So in KNN for distance calculation, you can use, oops, I'm not recording. Let me record. Yeah. So in KNN, we use distance we use distance formulas like Manhattan distance, Euclidean distance, and Minkowski distance formulas to calculate the distance between the new observation to the all the observations which are already present in the data set. So after calculating the distance, we have to select the number of nearest neighbors. So after selecting it, whichever the side, there are more number of variables which are near to the new observation, that new observation belongs to the class, the highest, the majority neighbors class. So this is what KNN is. Hope everyone has a very good idea about all these algorithms, right? Yes or no? Guys, you have any doubts till yesterday's class? If so, please let us know. So before going to the new algorithm, let me first talk about yesterday's concepts like confusion matrix, FPR, TPR, AUC, and ROC. So what do you understand by confusion matrix? What actually this confusion matrix is? I didn't tell you the definition of it, but I have shown you that, right? So can you please tell me what is that confusion matrix? Can you please tell me what's that confusion matrix is? What will be there in that confusion matrix? Guys, a small request. While answering the questions, please answer questions privately. While asking the questions, please ask the questions to everyone. All right? So confusion matrix is a matrix which will showcase the number of true predictions as well as number of false predictions. Yes, so that's what confusion matrix is. And what about TPR? Yeah. So TPR is nothing but true positive rate, and FPR is nothing but false positive rate. So what is the percentage of AUC curve which says the model is very best, which says the model is worst, which says the model is bad, and which says the model is good? Can you please tell me what is the values of all those AUC ROC curves? It's not regression, Sony, it's rate. Okay. AUC 1 is best, Haripriya, 0 is worst. Yeah. So AUC 0 is worst, best is 1, good is greater than 70%, bad is which is lying around 0.5 to 0.7. Right? So hope everyone have these clarity, right? So now let's see what are all these things. So now in this session, we will be talking about the evaluation metrics. So what are these evaluation metrics? Let's see. All right. Yeah. So for regression, what is the type of accuracy that you're using? For regression, what is the accuracy that we are calculating? And for classification, what is the accuracy class that we are using? Yeah. For regression, it is R2 underscore score. And for classification, it is accuracy underscore score. So now today, we will see what sort of mathematical concept is there behind this R2 underscore score and accuracy underscore score. All right. So these are all considered as the evaluation metrics. So for machine learning model, for a student, his percentage will be the evaluation metrics. But for the model, R2 score, accuracy score, AUC, ROC will be the evaluation metrics. So these evaluation metrics considers as consists of R2 score, confusion matrix. What is AUC ROC curve? How do you define AUC-ROC? How to speculate the performance of the model? Relation between sensitivity, specificity, FPR, and threshold. So in this topic, I will be covering all these things so that you will have a very good clarity of what we are doing for calculating the accuracy of regression as well as classification, right? So first, let's move on to the R2 score. So as soon as you see on the as soon as you see this curve, what gets in your mind, guys? As soon as you see this picture, what gets in your mind? Okay, that is linear regression. That's fine. What do you call this? So you call it as a straight line for the simple linear regression, or do you consider it as something else? That's really good. So this is called as best fit line for the linear regression. Yes. So not only linear regression, whatever the regression algorithm you take, okay, for calculating the accuracy, it will calculate the best fit line. So at the best fit line also you are calculating some error, right? Yes, you will be calculating some error, right? So that error will be used to find the accuracy of the regression model. So the error of the best fit line as well as the error of the as well as error of the average line are used for calculating the R2 underscore score, right? So this is the error for best fit line. And then you also calculate the error for average line. That means you will be taking y mean and you will be drawing a straight line at y mean. So from that you will be again calculating the error of this. So the best fit line error is considered as SS residual, and the average line error is considered as SS total. SS total. So with the help of these two, we will be predicting the R2 score. So basically R2 is nothing but R squared. R squared. So in functions, you cannot write R power 2, right? So that's the reason the class used for calculating the regression accuracy is R2 underscore score. But actually it is called as R squared score. So what is the formula of R squared score? Is equal to 1 minus SS res divided by SS total. So with the help of this formula, you will be calculating the R square underscore score or R2 underscore score for the regression. So did you understand how do you calculate the R2 score now? Any doubts here? Any doubts here? Guys, any doubts here? R2 score. Understood? Yes, R2 underscore score is used for finding the accuracy of the model. And how is that accuracy is being calculated? With the help of this formula. So R2 score is nothing but you can consider as R squared score. So R squared score formula is 1 minus SS res divided by SS total. So how do you get SS res? This is the error for the best fit line. This is the error for the average line. So again I am telling SS res. So whenever you consider any regression algorithm, you will be first creating an equation. After creating an equation, you will be drawing a straight line. After drawing a straight line, you will be calculating the error. Yes or no? Now you will move a straight line upside or downside. Then you find a best fit line. So how do you say this is the best fit line? Whenever the error is minimum. So that error is considered as SS res. That error is considered as SS res. And coming to the other one, SS total is error at the average of y. So y average is nothing but y mean. For suppose y mean is 3.5. So at that 3.5, a straight line is drawn. So after that, you will be calculating again yi minus y average whole square. Then you get this SS total. Once you get this, substitute these values in this formula. Then you get the accuracy of a regression model, which is R2 underscore score. R2 can be considered as R squared. R2 can be considered as R square. Got it, guys? Clear? Clear, Pramod? So you asked me to repeat it, so I have repeated it. Repeated it. Kavya, Pramod. Yes. Now, let's move on to the classification metrics. So classification problem, evaluation metrics. So in that we will be calculating the confusion matrix. In that, we will be calculating the FTR, TPR, AUC and ROC curve. All right. Now, next, let's see what is this confusion matrix is. So for suppose I have 100 observations. Sorry, this is 100 observations. In that 100 observations, these are the values. So how are these calculated? Now I'll take a small Word document and I'll explain you. So let's suppose this is predicted value. Let's suppose this is Y test. So I told you Y test is considered as a Y test is considered as the key paper, and PRED is considered as the prediction. So these are the answers given by the model, and Y test is the actual key paper. So my predictions are like 1, 0, 1, 0, 0, 0, 1. Okay. So these are the Y test values. These are the Y pred values. Okay. Now, confusion matrix is formed like this. So in confusion matrix, you will have 4 cells. So this cell is like true predictions. This cell is like true predictions. These two, the diagonal, these two, this one as well as this one are wrong predictions, right? So how do you calculate this? Now, actually, the answer is 1. The predicted is 1. So here, where am I supposed to fill the cell? Actual value is 1 and predicted value is also 1. So 1 is yes, no, 0 is no. Actually, it is yes, predicted also yes. So where am I supposed to put this number? Where am I supposed to put this number? Whether this is in the first cell or second cell or third cell or fourth cell. That is in the first cell. So, yes, 1. Now, actually, it is 1, but it predicted as 0. Actually, it is 1, but predicted as 0. Where am I supposed to put this? Actually, it is 1. That means actually that should be yes. But my model predicted as 0. So actually it is yes, but the model predicted as no. So that will be in the second cell. Good. Now the third one. Actually it is 0, but it predicted as 1. Actually, it is 0. It predicted as 1. So actually, that will be 0, but predicted as 1. So that will be in the third cell. Right? That will be in the third cell. Actually, that is no, but predicted as yes. Right? Now, fourth one. Actually, it is 0, predicted as 0. So actually no, and predicted also no. So that comes in this cell. This cell. Fine. So first 4 are done. 1, 2, 3, 4. Now next one. Actually, it is 1, and predicted also it is 1. So where am I supposed to put this cell now? Actually, it is 1. Predicted also 1. So actually, yes. Predicted also yes. So that is in the first column. Plus 1. Next. Actually, it is 0, but predicted as 1. Actually, it is 0, but predicted as 1. So that means third column. Plus 1. Yeah, next. Actually, it is 1, but predicted as 0. Actually, it is 1, but predicted as 0. That will be in the second column. Actually, it is 1, but predicted as 0. Actually, it is 1, but predicted as 0. Actually, it is 0, but predicted as 1. Actually, it is 0, but predicted as 1. Plus 1. Then 0 and 0. Actually, no, and predicted as no. Plus 1. So now the total are 2, 1, 3, and 3. Oh, sorry, this is not here. This is here, guys. 0 and 0, right? No and no. Here it will be 2, right? So now out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10 predictions, 4 predictions are correct predictions. Out of 10 predictions, 4 predictions are correct predictions. That means 2 predicted as yes, and actually also it is yes. 2 predicted as no, and actually as also no. But here, actually, the values should be no, but model predicted as 1. Here, actually, the values should be yes, but model predicted as no. That means 0. So this is how your confusion matrix will be formulated. Understood? Understood, guys? How is this confusion matrix formulated? Yes? Any doubts? If so, just let me know. Cool. Now, these columns are denoted with some abbreviations, not abbreviations, that column is denoted with some other value, some other name. So let's see what is that name is. All right. Now, so this is yes. So now you just consider yes. This is no, right? Yes means positive, no means negative. Okay. So here the column is yes column, all yeses column, right? So positive. No means here it is negative, positive, positive. This is no. No means negative. Negative. So this also positive. This is negative. As this cell is true predictions, so you call this as true positive. As this cell is false predictions, so you call it as false negative. In the same way, this is also false. That means wrong predictions, false. But this is the correct prediction. So you say it as true negative. So these are true predictions of yes. This is considered as true predictions of no. This is considered as false predictions of no and false predictions of yes. So did you understand how do you denote these cells? So this is called as true positive because positive means yes. Yes, he has disease. Yes, he will be quitting the bank. Yes, he has diabetes. It has yes conditions and this cell is the true predictions, correct predictions. So correct predictions are considered as true, wrong predictions are considered as false, yes are considered as positive, no are considered as negative. So these are true yes predictions, true correct prediction, yes prediction. So that's the reason true positive. These are correct predictions of no. So that's the reason it's called as true negative. This is false negative. This is false positive. Did you understand this? So this is true positive. This is true negative. False positive and false negative. All right, guys. Now, so actually no means what? No means negative, right? Remember, no means negative, guys. Okay. So no means negative. So that's the reason this is negative. This is negative. Yes means positive. So here you put positive. Here you put positive. These are true predictions and the correct predictions. So that's the reason it is true. This is wrong prediction. So that's the reason it is false. These are again false predictions that are wrong predictions. That's the reason this will be false. These are again true predictions. So that's the reason it is true negative. So did you understand, guys, this? Now did you understand? Any doubts, guys? Ma'am, I have one doubt. Predicted number, second row's answer is 3. Here, this one. This one, Srinath. Okay, this one. Is it 3? That is 3. So let's see whether those are 3 or not. Actually, yes, predicted as 0. So this is 1. Actually, yes, predicted as 0. Actually, yes, predicted as 0. Yeah, this is 3, guys. Yes, it is 3. Actually 1, but it predicted as 0. Actually 1, but it predicted as 0. Actually 1, it is predicted as 0. So this is 3. Oh, so you have to consider, and this also something, this also a bit different, guys. So I have considered the row wise yeses and nos, right? Actually, you have considered column wise yes and no, right? Actually, you have to consider row wise yeses and nos. So actually, yes. So that means these two becomes positive. So positive and positive. These two becomes no, right? So row wise this becomes negative and this becomes negative. Yes. Now this is true positive, false positive, true negative, true, false positive, and true negative. Now actually I have considered the row column wise things, but these are predictions, right? So predictions things are not considered, row wise are considered. So here you have s, so the whole row become positive, the whole row become positive, the whole row becomes negative. All right, the whole row becomes negative. So this becomes positive, this becomes positive, the whole row becomes negative, the whole row becomes negative. Now these are true predictions, so that's the reason you get it as, so that's the reason you it is said as true. As these are false predictions, these are denoted as false. Now this also false prediction. So false negative, this is a true prediction. So this is a true negative. So true positive, false positive, true negative, and sorry, false negative and true negative. This diagonal are correct predictions. This diagonal are wrong predictions. So this is what about your confusion matrix and denotion of confusion matrix. Next, how do you calculate TPR and FPR? Now you will get the formulas of TPR, you will get the formulas of FPR, and also you will get the formula of accuracy. So now until here, if you have any doubts, just let me know. నువ్వు చెప్పుడు కాదు ఏమో చెప్పు మళ్ళీ నేను చెప్పినాక నేను పిచ్చోని అయితా నాకు వెళ్ళాలనే ఉంది సాయి వెళ్ళొద్దని కాదు నువ్వు చెప్పు ప్రగతి కాలంలో ట్రూ ఆర్ ఫాల్స్ కన్సిడర్ చేయరా మ్యామ్? కాలంలో ట్రూ ఆర్ ఫాల్స్ కన్సిడర్ చేయరా అంటే, సి దిస్ సెల్ ఇస్ ద ట్రూ ప్రిడిక్షన్, రైట్? దిస్ సెల్ ఇస్ ద ట్రూ ప్రిడిక్షన్, అందుకే ఇక్కడ ట్రూ ఇచ్చాం. ఈ సెల్ వచ్చేసి ఫాల్స్ ప్రిడిక్షన్, ఇది కూడా ట్రూ ప్రిడిక్షన్, అందుకే ఇక్కడ ట్రూ వచ్చింది. ఈ సెల్ వచ్చేసి ఫాల్స్ ప్రిడిక్షన్, అందుకే ఇక్కడ మనం ఫాల్స్ ఇచ్చాం. ఈ సెల్ కూడా ఫాల్స్ ప్రిడిక్షన్, ఫాల్స్ అంటే రాంగ్ ప్రిడిక్షన్ అన్నమాట. సో అందుకే ఇక్కడ మనం ఫాల్స్ ఇచ్చాం. ఫైన్, ట్రూ ఫాల్స్ అయిపోయింది. ఈ పాజిటివ్ పాజిటివ్ నెగిటివ్ నెగిటివ్ ఏంటి? బేస్డ్ ఆన్ యర్ కాలం కేటగిరీ. సో బేస్డ్ ఆన్ యర్ రో కేటగిరీ. సో రో కేటగిరీ ఏంటి? ఎస్. ఎస్ అంటే ఏంటి? పాజిటివ్ కదా. సో అందుకే మనం ఇక్కడ పాజిటివ్ ఇచ్చాం, ఇది కూడా పాజిటివే. ఈ రో కేటగిరీ ఏంటి? నో. నో అంటే నెగిటివ్, అందుకే ఇక్కడ నెగిటివ్ యాజ్ వెల్ యాజ్ ఇక్కడ కూడా నెగిటివ్ ఇచ్చాం. డిడ్ యూ అండర్స్టాండ్ ప్రగతి? నౌ ట్రూ అండ్ ఫాల్స్ అనేవి మనం ప్రిడిక్షన్స్ దాని మీద డిపెండ్ అయి ఉంటాయి, కాలమ్స్ దాని మీద డిపెండ్ అయి ఉండవు. ఈ పాజిటివ్ నెగిటివ్ ఉన్నాయి కదా, అది రో మీద డిపెండ్ అయి ఉంటుంది. ఆల్ రైట్ ప్రగతి, అండర్స్టాండ్? Understood guys? No doubts till here? No doubts, because if you understand this only, then yeah, you're welcome Pragati. No doubts, right? Okay. Yeah. Now let's move on to the next topic, which is calculation of TPR, FTR and accuracy. All right. So I told you, right? This will be true positive, true negative, false negative. I mean, this is like idi ulta icharu, but this one is the proper formation. True positive, false negative and true negative. So here also they have considered as column positive and also that's the reason this is wrong. This is also reverse, but the actual denotation is this one. All right. So this is how you will be considering that. After this, you have to get to know about AUC and ROC curve. All right. So in AUC and ROC curve only we will have TPR, FTR and all. All right. So this AOC, I mean the AUC is considered as area underscore curve. So in classification problems, these are very much important. This AUC and ROC curve are very much important. Not just the accuracy is needed, you should also consider AUC and accuracy curve. So AUC and accuracy curve is plotted at various threshold settings. So I'll tell you what are these various threshold settings within few minutes. So you have to plot the AUC ROC curve at various threshold settings. Then ROC is the probability curve and AUC represents degree or measure of separability. Separability is nothing but how well your model is predicting yeses as yes, predicting no's as no. How well your model is able to distinguish between the observations. Whether is it predicting all the true prediction, all the yes predictions or yes as yes, or all the no predictions as no, is nothing but the separability is. So that's what it is written here. Higher the accuracy, better the model is. That means if it is predicting 0 as zeros and 1 as ones, then you will get the higher accuracy. So yesterday I told you, right, whenever AUC is 1, it predicted yeses as yes and no's as no. Did you remember yesterday? So whenever it is that, then your accuracy, your AUC will be very high. Now, the ROC curve, this curve is plotted with TPR against FPR. So FPR will be on the x-axis and TPR will be on the y-axis. TPR on the y-axis and FPR on y-axis and the FPR on the x-axis. So before this, let's calculate TPR. TPR is also called as recall. It also considered as sensitivity, and this is formulated with the help of true positive divided by true positive plus false negative. True positive divided by false negative plus true positive. So from where are you getting these values now? From where are you getting these values now? Where are you getting these values from? TP plus FN. You're getting that from confusion matrix. So you know true positive values, you know false negative values. So you can calculate the TPR. So true positive rate. Rate of positiveness in the data set. So true positive divided by true positive plus false negative. In the same way, FPR will be 1 minus specificity. 1 minus specificity. So what is the formula of specificity? True negative by true negative plus false negative. True negative divided by true negative plus false negative. True negative and true negative plus false positive. Now you got specificity. That's really great. Now FPR, I told you, right? 1 minus specificity, or you can also calculate it as false positive by true negative plus false positive. False positive divided by true negative plus false positive. So this is how you will be calculating the TPR, FPR. After this, you will be plotting the AUC, ROC curves based on the threshold. So after checking those thresholds, if suppose, let's consider an algorithm or a data set where here the red curve is yeses, the no curve is the red curve is yeses and the green curve is no. The red curve is yeses and green curve is no. It's just to visualize things, guys. This is not how your graph looks like, but consider this is true negative, this is true positive. That means positive as well as yeses as well as no's. If suppose your data set predicted no's as no's and yeses as yes, then AUC will be 1. Yesterday I've told you, right? So whenever you plot that AUC, it will be in this format. So yesterday I've also showed this in the form of pictures on in paint, right? So whenever your model is trying to separate the algorithm truly, then your AUC will be 1. Fine. If suppose your model is predicting positives as negatives and negatives as positives, then your accuracy will be 0. Then your graph will be in this way. So this is the worst model. Then if suppose 70% of your data is correctly predicted and 30% of data is wrongly predicted. So let's suppose out of 100 yeses, your model correctly predicted 70 yeses as yes and 30 predicted as no. So at that time, there will be some sort of overlapping. At this time, your AUC will be 0.7 and now your curve will be in this way. If suppose your model is unable to predict anything, it is predicting all as, 50% as yeses and 50% as no's, then your AUC will be 0.5 and your the graph will be a straight line passing through the 0. So this is how you will be plotting the AUC and ROC curves. All right, guys. Did you understand now? Did you understand now? Now, let's say, let's go to the yesterday's program. Let's go to the yesterday's program. And here we have calculated the, let's consider this KNN, okay? Let's consider this KNN. And now I have these values, right? Now, tell me the true positive rate and false positive rate of KNN. True positive rate and false positive rate of KNN. 2 minutes, guys. Guys, tell me. What is the true positive rate and false positive rate for the KNN? Calculate this, guys. You don't want to calculate this? One 57 divided by 1157 plus 47. Here I got it as 0.96. Right. Now, FPR, 0.610. Yes or no? Now, let's plot the graph. So AUC-ROC curve is plotted between FPR as well as TPR. FPR as well as TPR. Yes, false negative is 166. Okay. Yeah. Anyhow, we got 96 as the answer, right? Yeah. Now, FPR on the x-axis. So what is the FPR? This is 0.6. Yes. What is TPR? 0.96. Now, how am I getting a graph like this? How am I getting a graph like this? Can someone tell me? So here they said AUC-ROC curve is the plot between FPR and TPR. That's really fine. That's really good. So whenever I want to plot it, I just will get only one point. But After plotting that AUC, I'm getting something like this. Have you seen this? How is this possible? This is purely based on thresholds. This is purely based on threshold. So did you understand what I meant, guys? Did you understand what I meant? Did you understand what I meant? Yes or no? I have calculated my FPR and TPR. That's very fine. That's very good. I want to plot this. So when I want to plot this, I am getting only 1 point. But how am I getting the whole curve like this? This is purely based on thresholds. So here, whenever you see, there is something called threshold, right? So based on these threshold, please calculate FPR and TPR of Y test and the prediction. So what is this threshold now? I will tell you. So did you remember in sigmoid function, I have taken some sort of threshold. Did you remember? In logistic regression. Did you remember? What is the threshold that I've taken for logistic regression?